All right, so I think I'm recording. In this next, I think there's like 6 or 9 problems that all refer to these two this given information. Um, let's construct a right triangle that has angle A in it, and if the sine of angle A is 1/4, we can have the opposite leg be 1, the hypotenuse be 4, um, the the adjacent side be the square root of 4 squared minus 1 squared by the Pythagorean theorem, which is the square root of 15 if I've done my arithmetic right. And if we construct another right triangle with angle B, and if we just use radical 2 and 3 as the opposite leg and the adjacent leg, if we square radical 2, that's 2. If we square 3, that's 9, and 9 plus 2 is 11. So by the Pythagorean theorem, we have that the hypotenuse is the square root of 11. So rather than, this is going to be the easiest way to do these. In many of the videos, I've been illustrating how to use those identities, but I would never, do that if I was doing the problems and it was under these directions. The easiest way to do any of these trig ratios, if you can construct a picture of a right triangle, that's definitely how I would do it. So let's bring these two triangles with us. All right, so if they want the cosine of angle A, I don't have to worry about the information about B. So I'll just as I make these videos, I listen to Bob and Tom, and you guys can't hear it, but I can hear it through my headphones, and they've got a funny comedian on right now. The cosine of angle A is the adjacent leg over the hypotenuse, so I'm getting the square root of 15 over 4, and I'm done. If we go to the next one, bring our two triangles with us. We don't need the information about B, so we'll just use this triangle. The tangent is the length of the opposite leg over the length of the adjacent, and if we rationalize 1 over radical 15, we get radical 15 over 15, and there's our final answer for that one. If we, again, we're just using angle A, so we'll use the triangle that has A in it. The secant is a reciprocal cosine. It's the hypotenuse over the adjacent side. So it's 4 over radical 15. But we have to rationalize that. So when we rationalize it, we're just multiplying by radical 15 over radical 15, right? And 4 and 15 don't have any common factors, so we're done. The cosecant, we're just using the triangle that has the information about A. We're not using this one. The cosecant is a reciprocal of sine, so instead of 1 over 4, it's 4 over 1, which is just 4. The cotangent of angle A is the reciprocal of tangent of A. Instead of opposite over adjacent, it's adjacent over opposite, which is the square root of 15. Now this time, we're finally using the other triangle. So the cotangent is the reciprocal of tangent, so instead of opposite over adjacent, it's adjacent over opposite. Then we have to rationalize that. So if we have 3 over radical 2, that's 3 radical 2 over 2 is our final answer. And the secant is the reciprocal of cosine. So instead, cosine is the adjacent over the hypotenuse, so we just do the reverse of that, the reciprocal of that, the hypotenuse over the adjacent with respect to that angle B. So it's the square root of 11 over 3. And the cosecant is the reciprocal of sine. So sine is the opposite leg of the hypotenuse, so cosecant's the hypotenuse over the opposite. And if we have the square root of 11 over the square root of 2, we need to rationalize that. And we typically can combine these two radicals as a single radical. So we get the square root of 22 over 2. And I think this is the last one. The sine of angle B is the opposite leg over the hypotenuse. And if we rationalize that, square root of 11 over the square root of 11, that's the square root of 22 over 11. And I think that's it. So hey, I hope that helps, and I'll talk to you later. Bye.